Okay, let us now go to the central and inscribed angle, and we're going to refer that in identifying what are the degree measure of an arc. So if you can recall, your arc is you can have this arc here as long as the endpoints are found on the circumference. So this is an arc here. So let us try to name this arc AB. So that is arc AB. So if two lines are connected from the endpoints of the arc towards any point of the circle or towards the center, we can say that that is a central or an inscribed angle. So say for example here, if we have this center here, and let us try to name this O, our circle is O. So if we're going to connect this code's segment there, so we can now have, by the way, this line here, this segment is called the, yes, this is a radius, this is also a radius. So we now have, what kind of angle is this one? So that is the central angle. So we have here a central angle, and what is the relationship of this angle here towards this arc here? Okay? So we have a central angle, and that is angle AOB, and what is its relationship towards our arc AB? So what is the relationship of the two, a central and the arc? So if we have this one, whatever the measurement of our central angle here will be the same measurement of our arc here. So say for example, if our central angle is, let's say, the measurement of angle AOB, let's say for example, if that is 45 degrees, that is just the same, our measurement of our arc AB also is equals to 45 degrees. So therefore, we can say that our central angle and its relationship towards its arc is, they are congruent, they are equal. So we can say if this is 45 degrees here, this is also 45 degrees. Okay? So how about if we have an inscribed angle? Now, what is the relationship of the intercepted arc and this angle here? Okay, this is called the intercepted arc of our angle here. So we have an angle formed MPN. We have MPN, and we have our arc MN. So what is the relationship of our arc MN towards our angle MPN? So what is the relationship of the two? The relationship again of our inscribed angle towards our intercepted arc. Inscribed angle, this is called the intercepted arc. So the relationship of the two is this one. So if we have the measurement of our angle MPN, let us say for example the measurement of this one is, let's say, that is 50 degrees. Okay? Okay, so what is the relationship of the two? So say for example, if the measurement of our angle MPN, our angle here, is 50, for example, so what is the measurement of our intercepted arc MN? So the measurement of our arc MN is equal to 100 degrees. So what do you mean by that one? Okay? So say for example that this is 50 and again this is 100, it means that our arc MN is, yes, so we can say that this is twice the measurement of our angle MPN. So therefore, this 2 can only be equal if we have the half of our arc. So whatever the measurement, the half of the measurement of our arc is equal to the measurement of our angle MPN. Again, if this is 50, its intercepted arc is 100 degrees. Okay, I have here again a illustration of our circle. That we have a circle here is circle P. We have this diameter, we have this radius, we have this arc here, we have this arc here, and we have many things going on in this illustration here. So let us try first to identify what are the kinds of arc. So we have two kinds of arc. We have a minor arc and a major arc. By definition, a minor arc is less than 180 degrees. And the major arc is greater than 180 degrees. And if you have an arc that is equal to 180 degrees, that is a semicircle. So we have a minor arc. A minor arc is less than 180 degrees. A major arc is greater than 180 degrees. And a semicircle is equal to 180 degrees. So what are the minor arcs here? So always remember that if we're going to draw a diameter that cuts the circle into two equal parts. So the measurement there is, since the diameter cuts our circle into two equal parts, this is half and half. So we can say that since the whole rotation of the circle is equals to 360 degrees, half of this one is 180. So therefore, we can say that this arc here from U towards our S is a semicircle. Okay? From U, X to S also, that is a semicircle. So, and that measures 180 degrees. So we can say that arc ULS is a semicircle, and that is 180 degrees. Another one is arc UXS, that is also 180 degrees. So that is a semicircle. How about a major arc? So a major arc is greater than 180. So it means that its rotation starting from that point will pass through the half towards another point. So we can say that if this is 180 degrees here, so if we're going to proceed to this point from this point passing through our X there, we can say that that is a major arc. So our arc UXL, U passing through point X going to L is greater than 180, and this is considered as our major arc as long as that is greater than 180 degrees. Minor arc. Minor arc is an arc that is less than 180 degrees. So it means that 180 less than or less than the semicircle. So we have two in this figure here. We have a minor arc. Minor arcs. What are the minor arcs? We have arc LS and arc UL. So we have arc LS here and arc UL or arc LU. So these are our minor arc. So let us proceed now to the degree measure of an arc. Okay, using the same figure, number one, the degree measure of an arc. Number one, the degree measure of a minor arc is the measure of the central angle which intercepts the arc. So, say for example here, if we have angle LPU is a central angle, arc LU is an intercepted arc, therefore, if our measurement of our angle LPU is equals to 120, then therefore we can say that the measurement of our arc LU is also 120 degrees. Okay? So using our figure here, we have again angle LPU. Angle LPU is a central angle since the vertex is at the center. Arc LU, this arc here, is an intercepted arc of our central angle. The condition here is if the measurement of our angle here, this angle here, is 120 degrees, what is the measurement of our intercepted arc? So therefore, the intercepted arc of our central angle is arc equals, so therefore, this is also 120 degrees. Okay? For number 2, the degree measure of a semicircle is 180. So we have here an example. If segment US, this one here, is the diameter, then we can say that the measurement of our arc SLU is equals to 180, and the measurement of our arc UXS is also 180 degrees. Again, if we have this segment US is the diameter, our US is the diameter. Again, diameter divides the circle into two equal parts, and that is a semicircle. I know that is the, sorry, what is that? That is the, sorry, yes, that is the semicircle. Correct. Okay, that is the semicircle. So what is the measurement of a semicircle? So that is 180 degrees. So therefore, we can say that our SLU is 180 and UXS is also 180 degrees. Okay, last, number 3. The degree measure of a major arc is equals to 360 degrees minus the measure of the minor arc with the same endpoints. So, if the measurement of our arc LU is 120, then the measurement of our arc UXL is 360 minus 118. So therefore, what is the measurement of our arc UXL? Okay, so what do you mean by this? If our arc LU, so this arc here, LU, is 120, then our UXL, So since circle is 360 degrees, to identify our UXL, our measurement of our major arc, the major arc UXL is equals to 360 minus, no sorry, this is 120 minus 120 because our UL is 120 in order for us to solve our UXL. Try to correct your modules there. That is not 180, instead that is 120. That is only a clerical error there. Again, that is 120 instead of 118. So again, full rotation of the circle is 360 minus our LU is 120. So therefore, what is the answer is 240 degrees. Therefore, the major arc UXL is equals to 240 degrees.